All right, moving on to our second section here, we're going to be looking at our quadratic functions. So the previous one we looked at our quadratics and we kind of started our base with looking at the width of it and finding the basic vertex. This one's going to make it a little bit more complicated to find the vertex, but now we're going to be able to find it for any function. So any function that is a quadratic will be able to find our max or minimum. Okay, so starting off with finding our max and min. So when we have our max and mins, we have again our equation y equals ax squared plus bx plus c, our base function. To find the x coordinate of our maximum or minimum, we are always going to use the equation negative b over 2a. So as you notice with the previous example, or the previous section, where we had b was 0 because there was no x, 0 divided by anything is always 0. So that's why. So here we have our b value and our a. We need both those to help us find what the coordinates would be for our maximum or minimum. Now once we have our x value, what you're going to do is you take whatever you got equal to, so whatever this number is right here, and you're going to plug it back in to the x's to find the y. So you just substitute it back in, solve it all the way through, and it's going to find a y value for you. Okay, so that's how you find your x and your y. So let's say we want to find the maximum or minimum for each of these. So with the first one, we plug in our numbers. So we end up with negative 4 all over 2 times 2. Okay, this 2 is from there, this 4 is from there. Okay, and now we go through and we solve it. Now when we get that number, we get negative 4 over 4, which would be negative 1. So our number would end up being negative 1, and then we plug negative 1 back into our function. So negative 1 plugged back in, we get this 2 minus 4 minus 8, which gets us a negative 10. So our vertex, or our turning point, our maximum and minimum, would be located at negative 1, negative 10. Okay. Alright, so now with the second one, what you notice is that that b value, that middle number, is negative, which means when we plug it in, it's going to be 2 negatives in a row. It's going to be negative, comma, or parenthesis, negative 8, all over 2 times 1. Okay, and now we go through and we'd solve that one. So I'd get us 8, because negative negative is a positive, over 2, which would be 4, and then we plug 4 in to the equation. So we would go 4 squared minus 8 times 4 plus 2. Plus 2. So we'd solve that and we end up getting 14 as our answer. Okay, so that's how we do our maximum minimum. So that's how we do it. So now take a second, find the last one, see if you can find what the vertex is for the final problem. Okay, so now, with that last one, you should have went negative 12 over 2 times negative 3, which gets you a positive 2, and then when you plug 2 in, you end up getting 8. Okay, so that would end up getting your vertex, that ends up getting your number, and so there's our maximums or minimums. The first two end up being minimums, and the last one ends up being a maximum, because again, we're looking at the a value for those. So that's how you find your vertex for any quadratic function. Okay, so you do that negative b over 2a, get that number, plug it back into the function to find our other ones. Okay, so now the axis of symmetry. So I said previously that the parabolas are always symmetrical. Basically means that whatever it is on one side, it's the same on the other. Okay, there's a line of symmetry or an axis of symmetry. Now the axis of symmetry is always equal to negative b over 2a. Hey, that is interesting because we've seen that before, like 2 slides ago. That is because that's the x value of your vertex. So your axis of symmetry is always located at x equals whatever the x value is. It's a line, okay? It's a line with an equation of x equals, because it's a vertical line. It's going up and down. So if you know what the vertex is, you know what the x value is of that vertex, you know what the axis of symmetry is. It has to be that same number, okay? It's always the same. So if we look at this example right here, Okay, so we have this parabola that's opening downward, so it would have a maximum, okay, because it peaks out. That maximum is located at -3, -3, +1. Okay, that's where our maximum is located. After that, we want to know what our axis of symmetry is. Well, our axis of symmetry is, let's change it up right here, is going to be a line that goes straight through those points. So you see that blue line would be that axis of symmetry. It's going through our maximum, okay, at the x value, but you see you kind of have the exact same on either side. It's a mirror reflection of it. Okay, that's what our axis of symmetry is doing. Every parabola will have it, and it will always cross through the vertex of our function. Okay. Okay, so now last thing is our y-intercept. Okay, so the last thing that we'd want to be able to identify, we have our vertex, our axis of symmetry, is our y-intercept to help us graph these. Now, our y-intercept is actually the easiest one, because with the y-axis, or the y-intercept crosses the y-axis. And so if you have a coordinate plane, okay, what's the x value along the y-axis? The x value is always 0. So all we'd have to do is we plug 0 into every single x value, and we solve. Now, anything times 0 is 0, meaning that these cancel out, leaving us with just 9, which means y is equal to 9, which means our point would be 0, 9. So the first one would be 0, 9. The second one would be 0, -2, and the last one would be 0, -7. Okay, so again, you just take whatever that last number is, that c value. So our y-intercept is always located at 0, c. Okay, so whatever the c value is. Now, if there is no c value, then it's 0. So that means your parabola crosses at the point 0, 0. Okay. Okay, so when we are graphing, what you want to do is you want to find your max and min using your negative b over 2a. Okay, you want to find the axis of symmetry, same thing. You want to use your y-intercept, then you want to find the corresponding point. And what I mean by the corresponding point is that if you know that a point is to the left or to the right 2 up 6, it's also going to be to the left 2 and up 6. Okay, if you know a point is to the right 4 and up 8, then it's going to be to the left 4 and up 8. Okay, because they're symmetrical, they should have points that are exactly the same. Okay. All right, so let's say we have this example. So this example, we have we want to find our vertex, we want to find our axis of symmetry, we want to find all that stuff. Okay, so let's start with our vertex, which would be negative b over 2a, so it'd be negative 4 over 4, because 2 times 2. So that means it's going to be at negative 1. So we have our axis of symmetry right here. Okay. Next, what we're going to do is we're going to plug in that negative 1 into the function to find our maximum or minimum. So if we plug in a negative 1, we get a positive 1, so that's 2 minus 4 minus 3, which gets us a -7 plus 2 minus 5. So we end up with a -5. So we go down here, 1, 2, 3, 4, 5. So there is our vertex. Okay, so that red dot is going to be our vertex. Now the question is it opening up or down? It's opening up, because the a is positive, but then we also have our intercept. So our intercept is at -3, which means I can put a dot at -3. Now, when I talk about corresponding points, what I mean is that from here I go over 1 up 2, so that means I can go over the opposite direction up 2. And there is the start of my parabola. And then what I can do is I can pick another point going both ways, but I'm just going to rough sketch it the rest of the way up. So my parabola would look something like that. Okay. Okay, so let's say we have this next one, and we are going to be doing the same thing. So first thing I want you to do is I want you to take a second. I want you to see if you can find what the vertex is. Okay, so our vertex, which we should have, is located at 3. Okay, so our vertex is located at 3, which means we have our axis of symmetry here at 3. Okay, so now when we plug in a 3, we end up getting 31. So as you see, this one is going to be kind of way up there. I can say, let's see here, this is 10 dots up, so I'm going to have to go with, let's see, we'll have it go up by 4s, no, 5, yeah, let's go up by 4s. So 4, 1, 2, 3, 4, 5, 6, 7, 8. So it would probably be right around here. Okay, would be our vertex. This one, it's a very large, it ends up being about, what is it, 331, I believe. 331. It's opening down because the A is negative, and our y-intercept is at 4. So if I'm going up by 4s here, that means that point's there. I went over 1, 2, 3, so that means I go over the other direction, 1, 2, 3, and I have my other point. And then I have my parabola there, and I can keep it going the rest of the way. So I could find another point if I want, but I don't need to, because it's just going to end up being a negative number anyway. So yeah, so that's how we are going to do our sketches. So find the vertex, find the y-intercept, find a corresponding point, so another point that's across from it, usually across with the y-intercept, and then just rough sketch it. Okay, so you only really need 3 points for these is all I'm looking for when you're drawing them. You don't, if you want to do more, you can, and you can always check it with your calculators. Okay, so inequalities. So if we remember inequalities, when we graph them, and we'd have a line, we would, set it up, coordinate plane. This is going to be a straight line at 2, up 3, over 1, down 3, back 1. Okay, so there's our line, and then since it's like that, our first one's going to be a dotted line, okay, because it's not equal to. And then do we shade above or below? Since it's y is greater than, we shade above, which gets us looking like that. Okay. The second one, we start at -2. Okay. Remember, we have our functions. -2, we go up 4 over 1. Yada yada yada. This is going to be a solid line because it's equal to, and then we shade below it because y is less than. So that's just a real quick overview of our inequalities that we did a while back. Okay, and now we can attach those inequalities also to parabolas. And so parabolas or quadratics can also be inequalities. The dotted and solid lines still apply. So if it's got the line underneath, it's a solid line. If it's got no line, it's a dotted line. Okay, so those still apply. So sometimes you'll have a parabola with a dotted, sometimes you'll have a parabola with a solid line. Other than that, you have your shading. You're either shading above or below based on the vertex. So if it's y is greater than your function, you're always going to shade above where the vertex is. So if you're opening down, okay, you're going to be shading everything above this, so it'd be everything on the outside of the parabola. If you're opening up the parabola, you're going to be shading everything inside of it. Okay, so that's for that first one. For the second one, you're shading everything below the parabola, so that would be everything kind of on the underneath it. So if you're opening down here, okay, there's your vertex. You're going to be shading on the inside of it, and if you're opening up, below it is on the outside. So you're looking in your parabola to see, is it above or below? Is it inside or outside the parabola? Okay, and that's how you're going to graph your inequalities, is you're just seeing where do I shade it. Okay. All right, homework for this section is in section 2. Kind of covers everything that we've gone over. Make sure you work on all that stuff.